Okay. I just ate, my tummy is full, so here I am. I don't know what to call this. Wireless transmission of energy, radio waves, whatever. Wireless electricity. You see, I know language matters, but sometimes you just have to kind of throw it out there and let people decide. Here now I have got a cigarette lighter, you know. Tick, 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 tick. It's supposed to be Yuzu crystal or whatever the heck it is. And when you push it, there's two wires and it's high voltage, and then you see a little spark in here. Well, that spark sends energy. That's right, energy. What the heck is energy? You tell me. In this instance, they call it electromagnetic radiation, or electromagnetic waves, or signal, radio waves, or whatever the heck, depending on whatever kind of frequency. And so that it's all covered under electromagnetic energy. That covers whatever it is, and it moves in a certain type of a way, a certain mannerism between these conductors. You see, and here's one just like it on the other side. So these waves come and hit this one. Of course, here electrons move, believe it or not, because this spark causes electrons to move in here, kind of back and forth, and that causes the propagation. Energy get disturbed. It's a disturbed energy, so the electrons get disturbed by the energy that comes from here. Then it transmits energy and hits this antenna, and it disturbs the electrons here, and that moves back and forth, and that back and forth has a voltage, which I have put this thing. This black little guy. This thing is a transistor, and this see the thing lining up. This and this half of the antenna is hooked up to the what's called base. So when this thing fluctuates, it is a pressure or voltage, if you will, which causes current to go in here into this transistor. It's like a switch, acts like a switch, and that causes this side, which is, they call it the emitter, and that side's collector. See, there's three legs in here. It causes this one to connect to that. So here's negative, goes in here, goes through there, and there is a light bulb, and then it returns back to the power supply right there. So I am actually supplying power here. So in essence, this, why am I doing that? This thing will light up without this, because you can hook up this LED, one leg here, and it will light up. But it will not, it's not as strong. So that should actually, I should really be doing that, but I have to bring this a lot closer. But this will also do, except it's a little more brighter, and you can see it, because this, you can see that this actually triggers that to turn on. So it has a fact. That's the whole idea of this. That wirelessly things move. So where does it all come from? Where does it all come from? Let me show you the specs on this. this particular diode is 2N3904. So let me project the camera onto the screen so you can you see it? Can you see it? Let me see what's going on here. There you have it. So is the base, the emitter, and the collector. Okay. And right there is the data to it. So so the collector and the emitter can handle 40 volts. And I'm supplying 12.5 volts. And emitter base 6 volts. Maximum 6 volts. So what does that mean? All right, let's see what does that mean. Let's see what that means. That means that this guy cannot apply, this transmitter cannot apply, and this receiver cannot transmit more than 6 volts, supply 6 volts into this base before it burns them all up. But this is very high voltages in the thousands of volts. So how is that possible? Here's what's going on, okay? This base has a resistance. They don't call it resistance, they call it impedance. What does impedance mean? See, resistance dissipates energy. It gets hot, you know, it dissipates energy. Impedance does not dissipate. Impedance slows it down, you know, impedes it, it gets in the way. So the base of transistors, any of them, even, you know, any kind of these transistors, you know, they being transistor or being MOSFETs or whatever the heck, they all have high impedance. So it cannot, chances are very, even there's a high voltage, by the time it gets in, it gets watered down, plus its own impedance, so it's, don't have to worry about it. And so you saw this specs, let's see, the specs between, as you see, is a collector base is 60 volts, emitter base is 6 volts, and collector emitter 40 volts. And maximum current that goes through the between collector and emitter, you know, between here, is 200 milliamps. So this is not gonna, the chance of this burning is, because this requires 3 volts. You put more 3 volts in this, it burns. So it does not get, you see, it does not get 3 volts. It does not get 3 volts because, or more than 3 volts, because the base determines how much voltage can go through. See, that's how, even though, see, I'm supplying 12.5 volts, it should burn it up. See, the base, which is right here, gets the signal from here. So let's see if that lights up. Here we go. Let's see if that lights up. Oh, it sure does. This is about 4 inches away, 6 inches away. Can you see it? Can you see it? Yeah, it lights up. A foot away. Oh, yeah, it's still blinking. Still blinking. No, it's not blinking. It's still blinking. Okay, that right there is maxed out. So check this out. It will not. So I'm going to put the pin right here. That's the range for this setup. That's the range. Let's go. Does it light up here? It kind of does. Oh, it still does. Okay, still does. Right up right here, it still does. It doesn't. Now it's too far away. Here, it just about. Okay, there is just about. That's maxed out. That's maxed out. So watch what happens if you put Greater voltage. Let's find out. Greater voltage. See if that pushes the signal, okay? Let's find out. World's most powerful, whatever you want to call it, stun gun. Don't do this at home. It does, okay? Let's see then if it can shoot farther away. Yes. So higher voltage, more transmission, longer range. This is in the millions of volts. So now you know what's going on, what's happening, how this thing works. It's not the electrons that transport energy. It's energy that dictates electrons what to do. Electrons are simply kind of a roadmap for where the energy should go. It's like the electron sits on the road, and energy goes okay, good that way. See, so in the electrical system, the wires act as a direction. The wires act for the road, the highway for energy, so they stay closer. Some take off, but majority of them are around the conductors, and so you get a lot more energy through wires than wirelessly. Okay. Wirelessly, there's a lot of loss because energy. Evidently there's of course localized energy, and then the one that propagates and it takes off, just takes off. So, but the thing that transports energy is not the electrons. The thing that transports is the electromagnetic waves, and they call that photons or whatever. But the point is, the waves themselves, that it's not energy. See how interesting this is, because the waves stops and moves out of the system. So this is all a game of this abstract thing called energy, whether it's in the form of light, heat, or this thing, or my voice, or whatever the heck. Isn't that interesting? That is interesting. And it has a system. It has a certain science to it. So where did the energy came from? It came from this? Well, you tell me. Maybe it came from me. I'm the one that pushes it, right? So maybe it's my energy. But where did I get it from? It came from me wanting this to happen. Causing my hands. Oh, we're going to stop right there because it's a rabbit hole, okay? Until next time, you take care.